here's the deal. Here's the buzz. Here's what's happening. This is supposed to be a short video illustrating risk and return. We're going to look at expected returns for individual investments by looking at the probable outcomes. We're going to look at the risk measured by standard deviation. The wider the range of the outcomes, in other words, the higher the standard deviation, the more risk that's involved. We're also going to take a couple stocks, put them in a portfolio, and measure the beta of that portfolio and magically the standard deviation of that portfolio. If it all goes right, we're going to have the same expected return we had for individual stocks, but with less risk because we structure the portfolio properly. Okay, here's our simple problem. We have investment A, 50% of the time it's going to get us a 2% return, 50% of the time it's going to get us a 4% return. Investment B, 50% of the time it's going to give us a 1% return, and 50% of the time it's going to give us a 5% return. And what we're going to do is combine these into a portfolio in a few seconds here, half and half of each investment. But for now, let's look at individual investments. Let's find the expected return for investment A. Well, 50% of the time we get 2% return, and 50% of the time we get a 4% return. That means our expected return is 3%. If you want to see what that looks like in the arithmetic, I took 0.5, half the time we get 2%, plus half the time we get 4%. And then since I didn't type in 0.02 and I didn't type in 0.04, I divided it by 100 to tell me that the expected return is 3%. Same expected return over here. If you think about it, half the time we get 1%, half the time we get 5%. What's that arithmetic look like? Same thing. Half the time we get 1% return, half the time we get a 5% return. Since I didn't use decimals, I divide the answer by 100 to give me decimals, and we end up with a 3% expected return. But this investment A has less risk. Look how tightly grouped this is. The expected return is 3, this is 1 away, this is 1 away. The expected return for investment B is 3%, this possible outcome is 2 away, and this is 2 away. So it has a standard deviation of 2. So let's just look at the arithmetic that we're going to use when we calculate standard deviations. It's going to look awful, but it's really not that bad. Take the possible outcome of 2 minus the expected outcome of 3. That's 2 minus 3. Square that. Multiply it times 0.5 because it happens half the time. Add to that 4 minus 3, which is the expected outcome. Square that. Multiply it times 0.5 because it happens half the time. And when I add those two together, I take the square root of them and I end up with 1. Same thing over here. What we've got is the possible outcome of 1 minus the expected outcome of 3 squared times 0.5 because it happens half the time. The possible outcome of 5 minus the expected outcome of 3 times 0.5, or square that, then multiply times 0.5, and then take the square root of that, and you end up with 2. So both investments have the same expected return, but this one has less risk. If you want to look at it graphically, they both have the same expected return of 3%, but the outcomes for A are grouped more tightly than the outcomes for B, so we say there's less risk. A little hint here, you can also check your work on these things if you have a Texas Instruments BA2 Plus calculator. Go into the data menu, clear it before you start, and X1, let's do investment A here. X1 is 2%, so let's hit 2, enter, down. And let's pretend like there's 100 times that we do this investment. Well, 50% of the time, in other words 50 times out of 100, it will give us that 2%. X2 is the 4%. 4, enter, down. Again, we'll get that out of 100 outcomes, 50 of them will be at that 4% rate. Then go to statistics and make sure this is set on 1V. There's a bunch of different ways for your calculator to do statistical analysis, but what we want to do is to be sure to use 1V, one variable. We hit down, it tells us that N is 100. Yep, we talked about 50 times at 2 and 50 times at 4. It tells us that the weighted average, in other words, the expected return is 3. That's what we thought. This is the standard deviation if this were just a sample. But we think we've covered every possibility, so it's really a population, so it tells us the standard deviation is 1. So that's a good way to check your arithmetic on these things because it's easy to make a mistake. So let's talk about a portfolio where half the portfolio is investment A and half the portfolio is investment B. What's the expected return of the portfolio? Well, it's the weighted average. 0.5 times 3%, because half the portfolio is in A, plus 0.5 times 3%, because half the portfolio is in B, tells us that the expected return for the portfolio is 3. Next, this question asks us what's the beta of the portfolio. Well, the beta, remember, measures how much a stock moves in comparison to the market. A has a beta of 0.7, B has a beta of 0.6. We do a weighted average, just like we did on the expected return. 0.5 times 0.7 plus 0.5 times 0.6, and we end up with 0.65. In other words, halfway in between 0.7 and 0.6. All right, the standard deviation of the portfolio is magical, but a little bit intimidating at first. Hell, I'd be intimidated by this. But what we do is we're going to take the weight of the stock, weight of stock 1, in other words, 50% of the investment is in stock A. We're going to square that. Multiply it times the standard deviation of investment 1, square that, squared, plus the weight of stock 2 squared times the standard deviation of stock 2 squared, plus 2 times the weight of 1 times the weight of 2 times rho, the correlation coefficient that says how these guys are related, times the standard deviation of 1 times the standard deviation of 2. What do I mean by correlation coefficient? That's the measure of how two variables relate to each other. So look at these two guys, A and B here. A goes up, down, B goes up, down, down. We charted them out, they move in exactly the same direction. If you buy a share of A and a share of B, you really haven't diversified your portfolio. They're going to go up and down at exactly the same rate. So there's no diversification achieved there. Look at variables C and D. They move in opposite directions. This stock goes up and down and up and down. This goes down and up and down and up. They have the magical correlation coefficient of -1. We like negative correlation coefficients because they're in here, and if it's a negative number, it's going to make this number smaller, which is going to make this number smaller, which is going to make the square root of that number smaller. And that's what we want to do. We want to get as small a standard deviation as possible. So if we can get a bunch of stocks that move in different directions at different times, we can eliminate all the individual stock risk, and we can just be left with the market risk. And we like the market risk. That's why we're thinking about investing in the stock market in the first place. We don't like the individual risk that's associated with individual stocks. So in this example, we would take the weight of investment A, which is 0.5, square that, multiply it times its standard deviation, which is 1, squared is 1. Weight of number 2 is 0.5 squared times 2 squared plus 2 times 0.5 times 0.5 times -1 times 1 times 2. Take the square root of all that mess there, and you end up with a standard deviation of 0.5. So we have the same expected return for the portfolio, 3%, but we don't have 1 unit of risk, we don't have 2 units of risk, we have 0.5 units of risk. So by artfully crafting our portfolio, we can have the same return, but with less risk. All right, I hope that helps.